All right. We are starting a new lesson on interval notation. It sounds a little bit complicated, but it is actually very similar to what we've been doing. So we're just adding one more step, and the step is pretty simple. So our three goals, and you're going to recognize goal 1 and 2, because that's what we've been doing. You're going to be solving inequalities and graphing inequalities on number lines. So those parts should be review, but we always need more practice. And then goal 3, the new part, is going to be writing interval notations for inequalities. And interval notations are pretty simple, and I expect you will do very well. So the definition of interval notation is the beginning and ending numbers of a set. So what this means is if we had a number line that covered all of the possible numbers, we would, here on the left, all the way to the right, the smallest number possible would technically be negative infinity. And then we go through all of the negative numbers. 0 would be somewhere in the middle, and at the far right would be positive infinity. Of course, you can never draw a number line that's actually that big because infinity goes on forever. So instead of writing out a number line that goes on forever, we use interval notation. So if we have a final answer of x is greater than 4, and we started with our number line, so we've solved the inequality, starting with our number line. X is greater than 4, so that's an empty circle, and we are going to highlight to the right. We are going to now write the interval notation. So interval notation, and this is going to be covering all of the possible numbers that we can use. So our numbers are going to the right towards infinity. So our first number is going to be 4, because that is our lowest possible number. And I know the empty circle shows that it has to be greater than 4, but for interval notation, whether it's a filled in circle or an empty circle, we're going to be using the number that we solve over here. So our interval notation is going to range all the way from 4 to positive infinity. And that, those two numbers are the beginning and the ends of the possible answers. There will be some graphs where there is an actual, bottom or top that is not infinity, right? The interval notation could go 4 to 1,000 in some situations, but for all of your inequalities here with the number lines, you'll have a negative infinity or positive infinity as your answers. So our next example, if we solve an inequality and we have x is less than negative 3, on a number line, we have negative 3, negative 2, negative 1, negative 4, negative 5. We have an empty circle here, and we're looking at numbers that are less than negative 3, so we're shading to the left. So now for our interval notation, IN. I don't think that's the real mathematical abbreviation, but it's okay. Now, because we're looking at numbers smaller, the shaded or the highlighted yellow goes all the way to negative infinity, and it goes up to our answer, which is 3. notice that the numbers in interval notation do go from smallest to biggest. So up here in example 1, we went from our number to infinity, whereas on our second example, we went from negative infinity to positive 3. So that order does matter. All right, so some simple problems. You're going to solve the inequality. So in this case, we divide by, or subtract 4 from both sides first. We get 2x is less than 8. Divide both sides by 2. We get x is less than 4. So that would be your first step. Then you will graph it on a number line. 2, 3, 4, 5, and 6. Empty circle here. Looking at numbers that are less than 4, so we shade this way. And then for our interval notation, we are simply writing from negative infinity all the way to 4. So just one new step. Okay, one last example. We're going to subtract 6 from both sides of negative 3x greater than or equal to 15. We're dividing both sides by negative 3. So whenever you divide by a negative, we have to flip the inequality symbol. So x is less than or equal to negative 5. Number line here, negative 5, negative 4, negative 3. That is not a negative 2. It's a negative 6. And negative 7. We finally have a filled in circle because it's less than or equal to. We are shading to the left. And our interval notation, again, is from negative infinity, because we're shading all the numbers lower than negative 5, all the way to negative 5. So even though in example 1 we had a less than 4, we still use the number 4. Less than or equal to negative 5, we still had negative 5 here. So steps 1 and 2, you're solving the inequality and your number line are exactly the same. And then you are writing the lowest possible and highest possible number in your set as the interval notation. Good luck on your assignment. Let me know if you need help.